What we have here is a two-dimensional projectile motion problem. We're told that a cannonball is launched at a 30-degree angle and at a velocity of 100 meters per second. And we're asked to find the travel time and travel distance of the cannonball. So let's draw a picture of what that would look like. We have our XY coordinate axis here. This is Y direction, this is X direction. We have a cannonball that's launched initially at 30 degrees at velocity of 100 meters per second. And the path of the cannonball is going to look like this. It's going to come up, level out, and then come down and impact at some distance x final. And so what we're asked is to find the travel time, or the time it takes to get from here to here, as well as the travel distance, or essentially x final. So to solve this, we're going to need to use equations of motion. Since it's two-dimensional, we're going to have to use two different equations of motion. One for the x direction, one for the y direction. Now, your basic equation of motion looks like this. Your position at time t equals 1/2 times the acceleration of the object times t squared plus your initial velocity, call it v0, times t plus your initial position, or p0. Now for the y direction, what your equation of motion is going to look like is y at time t equals, your only acceleration is due to gravity, so we'll call that g. It's going to be 1/2 g t squared plus your initial velocity is going to be 100 meters per second, but that's not in the y direction, that's at 30 degrees off of the x direction. So we need to find the y component of this velocity. And so the y component of this velocity is going to be 100 meters per second times the sine of 30 degrees. So we have 100 times the sine of 30 degrees times t. And the initial y position is 0 because it starts at the origin. Now let's go ahead and simplify this. We'll insert some values here. For g, we're going to use -10 meters per second instead of the standard 9.81, just to make this a little bit simpler. So we're going to say that g equals -10, and the value for the sine of 30 is 0.5. So we're going to substitute in these values, and what we have is y at time t equals 1/2 times -10 is -5. So -5 t squared plus 100 times 0.5 is 50. So we have plus 50 t. So this is our equation of motion in the y direction. Now, if you look at this picture here, the cannonball is at a position of y equals 0 at two places. Y equals 0 is essentially this line right here. It's at a coordinate of y equals 0, here when it's launched, and here when it lands. So if we set this position equal to 0, we're going to have two solutions, one at time t equals 0, and one at our final time here, which is going to be the travel time. So we'll set this equation equal to 0 and see what we get. We have 0 equals -5t squared plus 50t. We'll add 5t squared to both sides, so what we get is 5t squared equals 50t. Now both sides have t, so you can see that if you substitute in 0 for t, what you get is 0 equals 0. So 0 is a solution, but let's divide both sides by t so that we can get the other solution. Dividing both sides by t changes this to a t, and it eliminates that t. So what we have is 5t plus 50, or t equals 10. So the time when it hits the ground over here is going to be 10 seconds. So that is going to be our t final. Now, what we need to do still is find the travel distance. So we need to write the equation of motion in the x direction and substitute in 10 seconds to find out how far it traveled before it hit the ground. So the equation of motion in the x direction is going to be x at time t equals, there's no acceleration in the x direction because gravity only works in the vertical direction. So we can ignore this term. It's going to be our initial velocity in the x direction, which is going to be 100 meters per second times the cosine of 30 degrees, because our vertical component was the sine, our horizontal component is going to be the cosine. So 100 times the cosine of 30 times t, and the initial position is 0. So this is our equation of motion in the x direction. Now, cosine of 30 is approximately equal to 0.866. So let's go ahead and substitute in 0.866 for cosine of 30 and 10 seconds for t, and that will give us the travel distance. So x at t final equals 100 times 0.866 times 10 seconds. And so what we got is 1,000 times 0.866, or 866 meters. So we've got our travel time here and our travel distance here.